Welcome to Scholars Edge Tutorial. In this video, we'll be looking at a topic called dimensioning, or you can say dimensioning of physical quantities. So if you are with your notes, jot this down. The definition or meaning of dimensioning. Dimensioning refers to how physical quantities relates to the fundamental quantities, especially mass, length, and time. How physical quantities relates to the fundamental quantities, especially mass, length, and time. So we're dimensioning physical quantities in terms of mass, length, and time, or you can say in terms of MLT. MLT means mass, length, and time. Now, another thing you should note under dimensioning is fundamental quantities. So note these fundamental quantities. I guess this is not your first time of hearing about fundamental quantities, but for those that don't know, jot down fundamental quantities. These are those quantities that cannot be expressed in terms of other quantities. Those quantities that cannot be expressed in terms of other quantities, they are what we refer to as fundamental quantities. And we'll be looking at some example of fundamental quantities, their units and also their symbol. Example of fundamental quantities, units, and symbol. Note this also. We have 7 fundamental quantities. There are 7 fundamental quantities. We have mass, length, time, temperature, electric currents, amount of substance, and luminous intensity. So these are the 7 fundamental quantities we have, their unit and the symbol. For mass, we have kilogram, which is the unit, and the symbol is kg. For length, we have meters, and the symbol is m. For time, we have seconds, the symbol is s. For temperature, we have Kelvin, the symbol is k. For electric currents, we have amperes, the symbol is A, capital A. For amount of substance, we have mole, the symbol is MOL, which is mole. And for luminous intensity, we have candela, and the symbol is CD. So these are the fundamental quantities we have. Next thing we'll be looking at is derived quantities, because it is actually these derived quantities that we will be dimensioning. It's more of the derived quantities that we'll be dimensioning. So what are derived quantities? These are quantities that can be expressed in terms of fundamental quantities. Quantities that can be expressed in terms of fundamental quantities are referred to as derived quantities. Example of these derived quantities are speed. We have speed, we have velocity, we have acceleration, we have force, we have area, we have volume, we have density, we have pressure, we have viscosity, we have discharge, we have mass flow rate. So we'll be looking at how we can dimension all of these quantities I just listed. All of these quantities, starting with speed. We'll see how we can dimension all of these quantities. So the first quantity we'll be dimensioning, the first derived quantity we'll be dimensioning is speed. Now, for you to be able to dimension any quantity, first of all, express them in terms of their formula. Now, to find speed, what formula do we use? Recall that speed is distance all over time. So if speed is distance all over time, next thing we express these individual quantities like distance and time in terms of their unit. What is the unit for distance? That is the next thing you should ask yourself. What is the unit for distance? Recall, distance is measured in meters. Distance is measured in meters. Time is measured in what? It's measured in seconds. So that's to say we have speed as meter per second. Now, recall that we are dimensioning in respect to mass, length, and time. Mass, length, and time, or MLT. We call it MLT. So looking at mass, length and time, which of them actually has the unit as meters? Looking at mass, length and time, which of them has the unit as meters? You can see that it is length. So the unit of length is meters. So this m we have here for distance, we will change it to L, which is length. That m symbolizes length. And for time, we have time as seconds. So MLT, which of them has the unit as seconds? We can see is time. So we change the S to T. We will change the S to T. We will change the S to T, which is the fundamental. So we'll change the S to T because we are dimensioning in respect to MLT. So for our meter, we have length as L, and for our second, which is time, we have it as T. Now that we have this length all over time, rewriting this, we have length per time, and this is our final answer. So if you are able to arrive at this point, you've successfully dimensioned the quantity speed. It's that simple, it's that easy. So looking at the second quantity, velocity, recall that the formula for velocity is displacement all over time. So first thing you need to know is, for you to be able to dimension any quantity, ensure you know their formula. Ensure you know the formula that is used to solve them. If not, you won't be able to dimension any quantity. So we have displacement all over time. Someone might ask, what's the difference between distance over time and displacement over time? Now, note this: distance is a scalar quantity, whereas displacement is a vector quantity. Why? Because displacement has direction. Displacement tells you the distance in which something moved and the direction in which that thing moved, whereas distance will only tell you like how far the thing moved. So displacement will tell you how far and in which direction it moved. So that is the difference between distance and displacement. So we can see that velocity is a vector quantity. As you can see, speed starts with what? S. Scalar starts with what? S. Let's say that is a scalar quantity, whereas velocity starts with V and vector starts with V. Tell you that is a vector quantity. So this just applies to these two. It doesn't mean that anything that starts with S or V is a scalar or vector quantity. So I'm just giving you a quick hack in mastering these two quantities. So next thing is displacement. What is the unit of displacement? It is also meters. And for time, we also have it as second. Now, if you express this meter over second in terms of MLT, we have meters as what? As length, and second as time. And finally, writing this, we have length per time. So that's all for velocity. Let's look at the third quantity, acceleration. Now, what is the formula for acceleration? Recall, acceleration is given as velocity all over time. We have velocity all over time. Next thing you ask is, what is the unit of velocity? We already know that velocity is a meter per second, and we've already gotten the dimension for velocity. Okay, let's just follow the due process. Formula for the unit of velocity, meter per second, and for time we have second. So if you have to express this in terms of MLT, how will you express it? Now recall that in number 2, which is velocity, we already have that velocity is what? Length per time. So length per time, and we know that our time, which is second, is equals to what? T. So we have L per T and T. Now if we have this, how can we rewrite this to actually suit what we are doing? How can we write this? So let me show you guys how to write this. It's also written as L per T divided by 1 all over T. So our job now is what? Change that division sign to multiplication sign, meaning that our T will go up and 1 will come down. And why did I include -1 as the power of T? Recall that whenever you have 1 all over anything, 1 over T or 1 over 2, to rewrite it, you can rewrite that particular thing you're giving me. Okay, let's assume it's 1 over 2. To rewrite 1 over 2, for the 2 to actually come up, that means you must attach -1 to the 2. So you'll be having 2 raised to the power of -1. So wherever you see anything raised to the power of -1, that stuff actually means 1 all over that thing. So 2 raised to the power of -1 also the same as 1 all over 2. Because we are saying t raised to the power of -1, it also means 1 all over T. Next thing you have to recall is indices. When you have two bases, when two bases are the same, what do you have to do? You have to just pick one. So we have L and we have T, we have T. So we have two T's here. So pick the L and pick one of the T, add their powers. So add their powers, -1 plus -1, which gives us what? -2. And this is our final answer. So this is the correct dimension for acceleration. It's very easy. First of all, we express velocity in terms of MLT, which is LT or L per T, and we have time, second, which is T. Next thing is what? To bring the T up, changing it to T or changing to per T. Yeah, T raised to the power of -1, and you add the powers by picking out particular base, which will now give us LT or LT raised to the power of -2. So it's very easy, something that's simple. Moving over to the next one, force. Our next one is force. Now, what is the formula for force? Recall that force is equals to mass times acceleration. Force equals mass times acceleration. So since we know that force is equals to mass times acceleration, what is the unit of mass? Recall, first step is to write the formula. Next thing is to express them in terms of their units. What is the unit of mass? Mass is measured in kilogram. And for acceleration is measured in what? Meter per second square. So let's see how we can express this given unit in terms of MLT. Now recall that in our MLT, M means what? M means mass, and mass is also given in kilogram. So we express our kg in terms of M. Then for our meter per second square, recall we've already dimensioned acceleration where we had L per T square. Here we had L per T square. So we don't have any issue with that again. So let's write out our given dimension. So this is what we have, and if you multiply this, we'll be having ML per T square. And this is the dimension of force. So you can see it's very easy and simple. Next we have is area. So what is the formula for area? We are given area as length square, or length times length. Area is very simple to dimension, though I'll still follow the due process so you'll be able to understand. Since we have area as length times length, and we know that length is measured in meters, length is also measured in meters. Instead of stressing yourself going through the normal process of length and converting to unit and then taking the dimension, we already know that length is part of MLT, so just write it out, length square. Length and length is what? Length square. So we already having as our dimension for area as length square, which if you write it well, it will equal to what? L square. like length square, L square. So looking at the next one, we'll be looking at volume. How do we dimension volume? Now, what is the formula for volume? To find volume, recall that volume is length times breadth times height. So since volume is length times breadth times height, since we have length times breadth times height, express them in terms of their units. We know that length is meters. Breadth, what is breadth? Breadth also means length. You're also finding how far. It also means length, or you can say breadth is the vertical length, and height also means how far, that is distance of something. It's also length. So we can say this is length times breadth times height, which is meters times meters times meters, and meter is what's length. So we are saying this is length times length times length, and it will give us what? Length cube, or you can say meter cube. If you have this as meter cube, that's to say volume, dimension for volume is what? L cube, because meter is what? Length. So we have the dimension for volume as L cube. Moving over to the next quantity, which is density. Now, what is the formula for density? Is one thing to ask yourself, what is the formula for density? Density is given as mass over volume. You know that density is mass over volume. So if density is given as mass over volume, recall we already did mass, where we see mass is kilogram and dimensioning for kilogram is what? M, and we had volume as length cube. So we can write this as M all over L cube. And writing this, we need to bring L cube up. So we are having M per L cube. That is ML to the power of -3. And that is our dimension for density. So the next one we have is for pressure. So first of all, what is the formula for pressure? We know that pressure equals force over area. So since pressure equals force over area, we already dimension force, where we say force is mLT to the power of -2, that is ml per t square, and we had area as length square. So we can just write this, no need to stress yourself, following the due process. So the only work we have to do here is how to bring L square up, how to bring it up. Recall I said for L square to come up, we change to negative, so it will be L to the power of -2. So we have it mLT to the power of -2 times L to the power of -2. So ml per t square to the power of L square. Recall what I said about indices. We pick out the ones that the bases are the same. Note, we are dimensioning in terms of mLT, so follow the sequence. Don't do anything like MTL or LTM. So you should always follow this mLT sequence. So first of all, we have our M there as 1. Next, we have 2 L's, so we pick out 1. The first L, it had the power of 1, and the second one have the power of -2. Since we are multiplying, remember in this, if you are multiplying, what do? You add the power. So 1 plus -2. And if you do 1 plus -2, if you do this, we'll be having 1 minus 2. And 1 minus 2, you are owing 2 and you paid 1. How much will be left? 1. So we still have -1. So that's to say our L here, we have a power of -1. And our T has the power of what? -2. So just write T to the power of -2. And that is our dimension for pressure. Very easy. We look at the next one, discharge. For some of you, this might actually be your first time hearing such discharge. So when we talk about discharge, what is formula for discharge? Discharge is simply volume all over time. That is discharge, volume all over time. So since we know that discharge is volume all over time, recall we said volume is L cube and our time is T, which is second is T. So we're having L cube all over T. Now recall what I say we are dimensioning in terms of MLT. We are not given M, so we just have LT. So for this T to come up, it will have what? Power of -1. So we are having L cube per T, or you can say L cube T to the power of -1. So this is our final answer, and this is the dimension for discharge. So next we have is mass flow rate. Now you might be wondering, what is the formula for mass flow rate? You are giving mass, you are giving rate. Whenever they say rate, what they mean? You're always talking about time. When you say when they say rate of something, like time takes for something to happen. So mass flow rate is simply mass all over time. Mass all over time. Recall our mass is what? M, because it's under MLT, and our time is T. So we have our mass flow rate as M per T, or you can say MT to the power of -1. So we've actually looked at 10 quantities and their dimension. Let's go further to the next quantity, which is the work done. Now what is the formula for work done? We know that work done is force times distance, and recall where we said force is ml per t square and distance, which is length. So we are having ml per t square over length. Now this is one mistake students do make. Sometimes they will mistake what they are supposed to multiply, they will divide. So I just this to grab your attention. We had work done as force times distance, which is supposed to be ml per t square times L, and I intentionally did ml per t square over L to see if you actually recognize the error immediately. So note this: wherever you are supposed to multiply, ensure you multiply, and where you are supposed to divide, ensure you divide. So what you are supposed to have here is ml per t square times L, and if we follow the law of indices correctly, we'll be having ml square per t square, and this is our final answer. Let's look at one more before we end this video. Let's look at power, and recall the formula for power is what? Work done all over time. Work done all over time. Recall we had work done as ml square per t square, and we have time as t. If you notice, we are actually dividing here, so be cautious of your basic operations. And if we follow the law of indices, we have ml square per t cube, and this is our final answer. So far we've been able to dimension 12 quantities. We've been able to get a dimension for 12 quantities, and let me give you guys one to try out. Try to dimension stress. I'll give you the formula also. Stress is force over area. Try to dimension Young modulus. Young modulus is stress over strain. Now for strain is a dimensionless constant, or is a dimensionless quantity. Reason because strain is given as elongation all over length. Elongation is what? Meters. Length is meters. So we have meter divided by meters, and if we divide, we have nothing left. We have just one. So strain is dimensionless quantity. So giving the dimension for stress is force all over area. Young modulus is stress all over strain. For energy is force times distance. Yeah, so this is all that you'll be doing for me. And if you enjoyed this video, please subscribe. So subscribe, like, and also comment. The once I give it to you, drop your answers in the comment section. So ensure you subscribe, like, and comment. Please subscribe, like, and comment. See you in the next video.